Welcome everyone to our weight and balance unit. We are in 7.5 and we are learning about helicopter weight and balance. I want to give you a case scenario where you, as a pilot, get to practice helicopter weight and balance in real time. You've already watched a video that I've posted for you about helicopter weight and balance, and at this point, let's put what we know to the test. You're a 170-pound pilot that has been commissioned by a group of adventurous Wanpaku sumo wrestlers. They are junior sumo wrestlers. And you are going to give 20-minute scenic helicopter flights in the San Francisco Bay. With the Robinson R-22, you're only allowed to fly one passenger at a time, and it has an empty weight of 880 pounds at station 104, and all other arms are listed in the form provided. The max takeoff weight is 1,370 pounds, and in all scenarios, you are flying with 10 gallons of fuel. All this information is already pre-populated for you on the form, and I have a QR code for the form right here. For any teachers that are using this as well, I have this spreadsheet located on the Google Drive, and you can post it to your Canvas page and include a link to the copy of it. But if you scan this, you should be able to come up with the Google form that we're going to be using to calculate. Very often we do weight and balance scenario calculations by hand, but in this case I wanted to use Excel to speed things up and to give you the chance to experiment really quickly. So we're going to do this first scenario together. You have a 200-pound sumo wrestling passenger, and in this case, are you within the CG envelope for the entire flight, empty and full on gas? Well, let's figure that out. So I have right here the setup of the aircraft. We have a basic empty weight of 880 at arm 104. I have all the arms provided for you. Please don't change those. We also have the right front, which is the pilot, that weighs 170 pounds at station 78. And we also have 10 gallons of fuel. It's 6 pounds per gallon. That's going to be 60 pounds of fuel in the main fuel tank at station 108.6. So the only variable we need to account for here is our passenger, which is in the left front right here. You may remember that that's 200 pounds. So I'm going to enter that into the spreadsheet right here. And notice that this spreadsheet is a giant IWAM chart. It does IWAM charts for the longitudinal weight and balance and IWAM charts for the lateral weight and balance. So what's going to happen here is we're going to take these IWAM values, and you're going to notice that I have total of everything with fuel at the beginning and total without fuel. The reason I want to calculate it both with and without fuel is because when you're flying the helicopter, the weight changes. So you start at the beginning, you're going to have a full tank, or at least the 10 gallons that we've prescribed. And by the end of the flight, you're going to be running pretty close to empty, and that weight change causes a significant balance shift or center of gravity shift. So you need to account for that and make sure that throughout the entire flight, and not just in one isolated moment, your aircraft is within balance. So we have these numbers right here, and what's going to happen is that we're going to use this to plot a point. We have a weight and an arm right here. And this is with fuel at the beginning. If you take a look over here, this is 1,300 pounds, and so 1,310 is going to be just above it, and my arm is at station 96.9. That's barely shy of 97. It looks to me like at the beginning of our flight, we are safely within the envelope longitudinally. And then at the end of the flight, we are at 1,250 pounds, which is about right here, and our arm has shifted because of the fuel loss to station 96.3. So that's going to put us about right here. So throughout the entire flight, we are safely within the envelope. And I'm going to plot these points on a Microsoft whiteboard so that way you could get a better look at it. It's going to take me a second. Okay, so I was trying some previous work on here, but forgive the intrusion. So let's take a look again at our chart. With our longitudinal weight, we have 1310 with an arm of 96.9, 1310 and 96.9. I'm going to highlight this in green. So 1310, 96.9. Let me show you that top axis. That's going to put me right here. Okay. And then at the ends of the flight, we've shifted to a weight of 1250 with an arm of 96.3. So 96.3 is right here, and 1250 is about right here. So throughout the flight, our center of gravity stays along this line, depending on how much fuel we have left in the tank. So now what we're going to do is we're going to take a look at our lateral weight and balance. And you're going to notice that at the beginning of my flight, we are at station 0.51, and that's negative, which means that we are shifted to the left. So that's going to be about right here on the chart. And again, that's at the beginning of the flight, so that's going to be represented by this point. So what I'm going to do, just to give you an idea here, is I'm going to take this point right here, which represents the beginning of our flight, and I'm going to draw a line straight down to this chart from that point. Let me line up my dots here and make sure that we are cooking with Crisco. And again, my number here was negative 0.51. And I want to make sure my line is straight, so I'm going to make an adjustment for that real quick. About right here should do it. 0.5. Yes, so this right here is my new point. So at the beginning of my flight, the lateral CG is going to be hanging about right here. And then, at the end of my flight, my lateral CG goes to exactly 0. Like, that's perfectly balanced. And it's at a weight of 1250. So what I'm going to do over here is I'm going to take this point at the ends of my flight. I'm going to, like I did in the previous one, draw a straight line down to it. So I'm going to add a line. Forgive how slow this is being, but, you know, we're all learning here, right? So I'm going to draw this line down to my center point, which is the 0.00 that I just showed you on the spreadsheet. Going to make sure that it's a perfectly straight line, or as perfect as I can make it. Okay, yeah, that looks pretty straight to me. That fits right on the line. That's pretty good. I'm going to switch to my pen, and I'm going to mark it right here. So, again, not a perfectly straight line, but if you zoom out, what you can clearly see is that when you have a 200 pounds junior sumo wrestling competitor in your aircraft, in your Art Robinson R-22 in the passenger seat, you are within the safety envelope longitudinally and laterally. So my invitation to you is this. Now that we've done scenario 1 together, you're going to be doing scenario 2 as partners. What you're going to do is you're going to have a slightly heavier sumo at 230 pounds sitting in the passenger seat who also wants to carry 20 pounds of camera gear. So again, you're going to make that adjustment here at 230, and then under left front and baggage, you're going to make that adjustment here. You don't need to redo the adjustments here because these automatically update. When you update these, the weights down here automatically update. You update these, you read out the numbers, you eyeball them on the graph, and if you find that you're within the center of gravity envelope, which is this shape here and here, then great. And if you're not within the center of gravity envelope, then you may need to make some shifts and make adjustments to your weight. So I hope this activity gives you the opportunity to really explore weight and balance. I hope it's engaging to you. And most importantly, thank you for taking the time to learn with me throughout this entire class. This is our last activity together. And my hope is that you've found this curriculum enjoyable, that you've been able to learn something important, and that you're going to take this on to become the next generation of great aircraft maintenance technicians. For once and forever, Clancy over and out.